All right, here we go with the actual area problem. I'm going to show you kind of a long method and where it comes from, and then we will show you the formula where we're using limits to find the area underneath the curve. Again, this is just a review and reminder of all your formulas here for the summation. All right, finding area under a curve. You're going to use rectangles in order to find the area under a curve. If I have this function right here, let's try this again. I got this function here. It's the quadratic, so it is shifted up 4. It's opening down because it's minus x squared, and we're going from 0 to 2. Well, what I know is that I know this quadratic actually crosses the axis there at 2. Well, what I want to do is I want to use 4 rectangles here to find the area. And when I do that, what you do is you divide your interval into 4 parts. So I've got 4 rectangles here. Each of these segments are half a unit. And so I want to find the area of this rectangle here. So I'm going to have my first rectangle, so rectangle number 1, plus rectangle number 2, plus rectangle number 3, and plus rectangle number 4. And the rectangle number 1 is this first one right here. It's going to be red, so my dimensions are the length is 1/2 and the height is 4. So 1/2 by its height, which is 4. So what we know that is 2. Plus, now my next rectangle here, what I want to do is I want the rectangle to go all the way over from 1/2 to 1 and all the way up to wherever the function is equal to 1/2. So I'm going to do f of 1/2. And if I evaluate that at 1/2, that's 4 minus 0.25. So 3.75. So my length is 1/2 and my height is 3.75. All right, now rectangle number 3. Rectangle number 3, let's do this one in green, has to be from when f is equal to 1 over and then down. So I want to find f of 1, and f of 1 is equal to 4 minus 1, which is 3. So plus, again, another half unit, 1/2 times 3. And then my last rectangle, let's go back and do that in red. My last rectangle here would be right here. So I need to find f of 1.5 and f of 1.5. So that's 4 minus 2.25. So that's plus 1/2 times 1.75. All right, so there you have it. These are each of the rectangles. Your rectangle should start and always be slightly above. So each interval you go and you evaluate the next point. So I've got my first rectangle over to 1/2. The next rectangle has the height of at x equals 1/2. The following rectangle has a height at f equals 1, and so on. Okay. So each of these, when I evaluated the 1/2, when I evaluated the 1, they were representing the function. So how high the function is, or these are the x values. So when I go ahead and simplify all of this, I get an area that would be equivalent to 6.25. All right, obviously we have better ways to do that. We want to, in fact, do it for infinitely many rectangles. So as the limit approaches, where an n value approaches infinity. Okay, and we will go ahead and look at a formula for this. And here is your formula. The formula is for a function y equals f of x. It's going to be bounded by an interval, so y equals 0. So above the axis, x is in between a and b, so that would be whatever interval we're finding the area between. So just to give you an idea of what this would look like, if I have this curve here, and I'm finding the area between two intervals, let's say between this a value and this b value, then the area would be here. So this is the formula that we use. It's the limit as x approaches infinity of the summation. And this summation right here, this should be f of all of this, f of all of that. Basically what we need to do is we need to substitute my a and b value in, the beginning of the interval and the end of the interval, and then we will substitute and then evaluate the limit after working with all of our summation formulas. All right, we are back at it here. This is pretty much what we're doing, the same example, except we're actually going to find the real area and not estimate it. Finding the area of the region bounded by the function and the x-axis, x equals 0 and x equals 2. So here's what we've got. The function here opens down. We're finding the area of this red shaded region, and we have to follow this formula right here. So in order to follow the formula, I need to know what a plus b minus ai over n is. I need to know what that is. Well, my a value here is the beginning of the interval. My a value is 0. My b value is 2. So I'm going to go ahead and substitute in here and get the result of this so that I can write out my formula. So we've got 0 plus 2 minus 0 I over n. So really what I've got, and this is with, we've got some parentheses around this b minus a, but it's 2i over n, and so that's pretty much what we've got going on here in this expression. And something else here with this expression is that we've got to look at evaluating the function at that expression right here. So we are going to do f of 2i over n. Okay? When I do that, so I'm going to take, now it's the limit as n approaches infinity. Having a problem with my pen here today, it's getting kind of sticky. As n approaches infinity of the summation, and as I goes from 1 to n of, and then this is where we put in what we know, okay? If I evaluate the function of 2i over n, I've got 4 minus 2i over n squared. Now here's where I got the 2i over n. Again, I did the a plus b minus ai over n. I put in 0 and 2. So all this comes from the interval. 0 is the a value and 2 is the b value, and we're going to substitute right here. And then I got 2i over n, and then this is f of 2i over n. I put it right in here for the x. All right, and then in the rest of the formula, here I'll show you the formula again. We're going back to the formula. I have to do b minus a over n. Well, b minus a over n is again 2, so multiply by 2 over n. There's a lot of different ways that we can evaluate this, and here's what my recommendation is. Let's go ahead and FOIL or distribute here the 2 over n and try to work with this exponent. So this is going to equal, and it's still the limit of, so the summation as I goes from one to n of, this would be 4 times 2 over n, which would be 8 over n. And then we've got 2i over n squared, so that's 4i squared over n squared times 2 over n. So 4i squared times 2 is 8i squared over n times n squared times n is n to the third. So I would recommend go ahead and separating the sums. Okay, and my sum, so I still have the limit of, as n approaches infinity, of the sum, and when I separate these sums, I'm going to go ahead and put the coefficient in front, so 1 over n of the sum of 8, and the sum goes, I is from 1 to n, and minus, I'm going to do 8 over n to the third, sum of I to the second. All right, so we got the limit, so this equals the limit as n approaches infinity and I've got my summation here. I'm going to go ahead and take the summation symbols out of there. So I've got 1 over n, and that's multiplied by 8n. Minus 8 over n to the third times, and if I use my I squared, and when I use my I squared, it's going to be all that part's FOILed out. It's 2n to the third plus 3n squared plus n all over 6. And as much simplifying as I need to do, I will, but otherwise I'm going to go ahead and take the limit as soon as I can. So I've got the limit as n approaches infinity. This pen is awful tonight. I'm going to go ahead and multiply 1 over n times 8. So 8n, that's going to give me 8. Minus the limit as n approaches infinity of, and I'm going to go ahead and distribute this out as well. So if I distribute the 8, I've got 16 n to the third plus 24n squared and plus 8n, and this is all over 6n to the third. So the limit here of the first part, the limit of 8 as n approaches infinity, this is equal to 8, and then minus, and this limit here is 16/6, because my degree is equal 3 and 3, so 8 minus 16/6. And so this equals, if you want to evaluate that, 8 minus, and shoot, you can even reduce this down here to 8/3, and then change the common denominator to be 24/3. Minus 8/3. So 16/3 is our final answer. 16/3. That's the area of this curve underneath the interval here, 0 to 2. All right, in this next problem here, let's go ahead and set up what we know. So we know that A is equal to, and then we'll do B is equal to, and then we'll do the interval. Find the area of a region bounded by the graph of f of x equals 1 plus x to the third between 0 and 4. So A is 0, my B is 4, and let's do this. B minus A over n, A plus B minus A over n, if I do all of this times I, what is this expression going to give me? Well, I've got 0 again, so 0 plus 4, so it's 4 over n I. This is what we're going to evaluate. We have to find f of 4 over n I. All right, so we've got the limit as n approaches infinity of the summation as I goes from 1 to n, and that summation would be, I got to find f of 4i over n, so that's going to be 1 plus 4i over n, and that's to the third power. And then multiply that by the 4 over n. All right, this is what we're going to simplify, and this is what's going to give us our area here. The first thing that I'm going to do is I'm going to go ahead and work with this 4i over n to the third and try to write out my summation a little bit better here. So we got the sum of, as I goes from 1 to n, and my summation here, I would have 1 plus, and if I take 4i to the third, that's 64 I to the third over n to the third. And then, of course, I want to multiply that by 4 over n. When I do my summations, I like to distribute that 4 over n and then use my summation and separate it. So the limit as n approaches infinity of, we got the summation I from 1 to n, and I'm going to distribute now that 4 over n. So we've got 4 over n, and then it's plus, if I multiply the 64 times 4, that's 256 I to the third over n to the fourth. All right, now what I'm going to do is go ahead and separate my limits. I'm going to separate my limits and then bring my coefficients in front. If you want to pause the video right now and then kind of, try to do it on your own, I know I'm going to go ahead and see if I can get this pen to work a little bit better. All right, so this is what it will look like. The limit as n goes to infinity of, I went ahead and separated each having its own sum. And the 4 over n here becomes 1 over n sum 4. And the 256 I to the third, so I put the 256 and the n to the fourth out in front, and then the I to the third. It's time to go ahead and substitute. So we're going to have the limit as n approaches infinity. The summation of 4 would be 4n, so we'd have 1 over n times 4n. And then we've got plus 256 over n to the 4th. And I have to multiply that by the power of 3 here on my I. And then again, I want you to use the expanded version of that. That's n to the 4th plus 2n to the 3rd, n to the 4th plus 2n to the 3rd plus n squared all over 4. Now, if I truly multiply these things out and I take the limit, it's going to be the limit as n approaches infinity of, the n's cancel here, so of 4 plus, again, the limit as n approaches infinity. If I multiply here, I have, I'm not going to do any simplifying, I'm just doing 256 n to the 4th plus 512 n to the 3rd plus 256 n to the 2nd all over 4n to the 4th. So here's what we're looking at. The limit here of n goes to infinity of 4. All right, so that limit here, this first limit right here is 4. I'll put my answer up here on top, so it's 4 plus, and this limit here, if we compare their degrees, we've got a degree of 4 on top, we have a degree of 4 on the bottom, so you take the 256 divided by 4, that's 64, so the area is the sum of those, which is 68. 68 area of this region. All right, so there's one more problem left here. I'll start it and get it set up for you, but I'll let you try to finish it. Here's what we've got. Find the area of the region bounded by the graph. And we need to list our A. We need to list our B. And then try to figure out what we're going to substitute for the f of A. Okay, so my A is 3, my B is 6. So if I do A plus B minus A over n times I, then what it would look like is this. So you got 3 plus 6 minus 3, so that's 3 over n I. This is what you're going to substitute, f of that, into your function. So I want to have you go ahead and go through that process and see if you can find that limit, and then I'll list your final answer. All right, so here's your solution, and I'll tell you kind of what I did overall. I went ahead and substituted the 3 plus 3 over ni right here, and then I simplified a little bit here. And then looking at this next line, I FOILed, combined like terms, and then I distributed the 3 over n. So here's where we're at. I distributed the 3 over n right here. So this is after the FOILing and after adding the 5 plus the 1. And then I get this expression after distributing the 3 over n, and then I separated them into individual summations. You can check out your work there. And then I went ahead and brought the coefficients out in front here, evaluated the summations, and then as I continue to simplify everything and do the limits, I get 18 for the final area.